So hello again to the programming bootcamp. My name is still Gabor Szabó. Nóra Charles is still with me. Hi, Nóra.
Hi.
I'm really happy that we can continue this, and I hope you managed to solve the exercises. So how were the exercises?
I think they were all right. There was one exercise, if I remember correctly, where you said we could do another version, which I think would require loops again. So I had an idea of how we would do that, but obviously I didn't know the loop commands yet, so I didn't do that part. But the rest was fine, I think.
Okay, so let's just go over quickly of what, the solutions I have. Let me share the screen. And so this is just the main slide, and then here we were in the strings chapter at the end where we had the exercises. And let's go over what do I have here. I think I haven't mentioned it at the beginning, but they're like the standard thing that the way I like to teach, or the way I teach, is that whatever the slides I have, and then I show them, and then almost all the time I find issues with my slides, a bug here, a bug there, and sort of I think I mean, if someone expects that everything is going to be perfect, well, unfortunately that's not definitely not how my slides work. But I think in general that's how things are. So, but every time, like during this video was as well, we found a couple of things that we then improved. So hopefully for the next time it's going to be better. So let's look at the exercises. So one string is if one string is in another string. That was the question here, I think. So we used the sys here to get the two strings from the command line. Apparently here I expect the short string to be the first, at least based on the text. So if I don't get the 3 parameters, so it's not exactly 3, then the program exits. Now there's actually a new construct that I just noticed. Okay, well, I'm inserting all of these new constructs that we haven't learned. So then anyway, I'll learn about these, that if you put an F character at the beginning of the strings, then you can actually embed in the curly braces variables. And then Python will replace the variable with its content when the string is created and when it's printed. We'll go over this later on, but apparently as I was preparing the exercises, I didn't think that much of, okay, when I'm showing this, I haven't taught that part yet. Okay, whatever. It's not that critical in the end, I think. So then I take the 2 parameters, so sys argv1 and 2 into 2 variables, and I just more or less arbitrarily call them string and text. And then I check with if string is in text. So if string in text, that's the context. If it is, then we get, using the index function, we get the location. I'm not even sure that the original exercise asked for the location, but here I'm showing the actual location where the first string was found in the other one. And if string is not in the text, then I'm just printing out it's not in the text. I guess I'm not sure. Maybe the original idea was, I don't even remember now, that to check which one is in which one. In which case you would probably just ask if the first string is in the second one, and if it's not, then you ask the other way. And if it's still not, then you can say none of them is in the other.
Yeah, that was my solution.
Right. Yeah. So I solved a different problem here. But yeah, this happens when I have well, in these slides, when I have an exercise, I solve it, and then I have a better idea for the exercise and update the exercise, and I forget to update the solution. Okay, so the comparing the strings, basically, so here, the first thing that I ask, in this solution at least, is the mode of comparison. So whether it's length-based or ASCII. And let's try this. So it's example strings compare strings. slides, Python, examples, strings, Python compare strings. I think this is the one. So it asks for length or ASCII, and the output is not really nice, I think. So it has a square bracket at the beginning and length and the pipe and ASCII. And here there's another pipe for some reason. Yeah, normally I think this should be a closing pair of parentheses, closing square bracket. That's what my intention was. And this is sort of an accepted way of showing if you have various options to type in, and then you put it in square brackets and the list of the values separated with pipes. That's sort of the common way. So definitely there is a bug here, but beyond that, that's the idea. And then I can type in now, let's say length. I'm not sure that actually this is a good idea to have this kind of interaction with the user, because now I'm actually requiring the user to type in correctly a word. And if I make a typo now, then the program obviously probably won't behave correctly or won't do what I meant to do. And it just makes it difficult to provide the input. So maybe it's not a good idea to do this. And so hello and A, B, C, D, E. Actually, let's make it shorter. Is wow, what an error message I got. Interesting. So what happened here? Let's look at this one. So it's a name error. Name str2 is not defined in line 10.
So you wrote string 1 and string 1 in. This, so you overrode the first string with the second input.
Right. I didn't even think about this, but I just created a really nice exercise of how to find a problem and how to debug one. Okay, so let me try to fix this one now, which is, sorry, it's in the not basics, it was strings, right? And in that was compare strings. So first of all, this was the square bracket, and this was supposed to be str2, 2, not 3. Okay, so let's try to run this again. And length, so hello, ABC, and whatever true. So, well, okay, I'm not really satisfied with my own solution. Okay, it says true. Why does it say true? What do you say?
Yeah, it's not supposed to say true.
Yeah. So I guess my solution is not finished yet here. Okay, so let's try to do it now. Okay, can you help me? Telling me what should I do?
I can't really see yet what the problem is, right? So
let's go over.
Yeah. So you say if the mode input is length, which it was in this case, then you should print the length of string 1 and the length of string.
Well,
oh, right. So it's just a comparison, but you didn't print which one is bigger or not.
Yeah, I mean, okay. So I think I have an idea. So we would print out first, either the word first or the word second, and then is longer.
Yes.
So I would say something like print, and I say first, if this is true, else second, right? So
wouldn't you want to do 3 options here? What if their length is equal?
Right, okay. I didn't think about it now. Okay, good idea. So now I have to do this. Okay, so totally different one. If there is one of them is bigger, then we'll have to go print first is longer, right? And then we have What do we have here?
Then elif, or yeah.
The other thing.
Yeah.
Yeah, okay. So let's say this one, and then I copy this command.
And then the second is longer.
Second is longer, and then I have else here. And say print.
Very cool.
Equal length. Okay. So let's see if this works, and then we'll finish. Stop with this exercise making, because that's not really point of the video. So length, and then hello and ABC, and first is longer. So seems better. We could actually check the other ones, but I wanted to take the opportunity to show another problem that just people might encounter. So I just remove the colon, which happens a lot to people, that they forget the colon after the else or after the if. And this is sort of the error message they get. So they get a syntax error, not a lot of text. The nice thing is that there is this the sort of arrow thing, a caret, but it points to the else. It also says line 14. So basically, this is the clue telling us that something is fishy there, and we need to look at that part. It doesn't say, it doesn't really know that the thing is that we were missing the column. What happened? Let's see this one. So I'm not sure if you get the same error there too. But yeah, so it's the same error message. Okay. I like showing error messages because people do encounter the error messages, and it's better to see it and then have some explanation than just out of the blue receive it. Even then, it's at the beginning, it's frustrating because you don't really know where to start it from, but it can help seeing that. Okay, so I guess I have to continue with the exercises here and finish them, the solutions. I have to do them myself. So there was this ASCII thing. So we check again the length, how many parameters we get, and if it's not exactly 2, then we complain. And then otherwise we take the first element and code order it and print out the result. And the other direction is the usage message is just slightly different. So it says string, and then the call is instead of well, yeah, this is a loop now. So okay. Right. So this is would work on each character by itself, not on a single.
Well, where do you define the variable CR in this code?
Right. Let me just check.
Or do you need to at all?
No, I think that's the next chapter, and then I can.
Right. Okay.
Yeah, loops. That's the next chapter. Okay.
Great.
So we're going there now. Okay. Good. So let's go to the next chapter now, loops, because that's gonna be much more fun, hopefully. So far we learned about statement after statement. We looked a little bit about functions, not much, where you would direct the execution path to some other location in your code. And we saw the if statements with all the conditional statements that can do either this or that. But there is another major concept in programming, which loops, that can do something repeatedly or something similar repeatedly. And it's a very, very important concept in the end. In general, in most programming languages, definitely not all, there are two loop styles. One of them is called a for loop, and the other one is called a while loop. In Python, it's actually for in loop and while loop. It's slightly difficult to exactly decide when, describe upfront which one to use when. But in general, I think that you would do a for in loop if you have a set of items so something, I'm using the word set because it's a list of items or it's a bunch of things. Okay, so it's not the right programming term here, but so you have a set of items and you want to go over each one of them. Okay, so you know upfront what are you going over, and when it ends, then it ends. And the while loop you would normally use if you would like to repeat some action until some condition is met. Okay, so I make 3 loops around the building. That's a for loop, and I go around the building till I get tired or till the rain starts. That's more or less a while loop. Okay, that's sort of the 2 main differences. Though theoretically you could implement one with the other, but that's not the point really here. Okay, so let's look at the for loop first. So here we have a for loop on a string. We have a string which is just a txt variable called txt, and this is how the for loop looks. So it said for some variable in some other variable, and then the colon and the internal part of the loop. This expression says basically go over each element of that txt. Each element on its turn put the current element in the variable called c, and then do whatever stuff is written here inside. I have only one statement here print, but you can have several statements inside. Again, indented to the same level, that means they are inside. Okay, so your previous question, where do I define the C? I don't, the for loop automatically puts the current value in it. And because it's a string, the txt is a string, so it goes over character by character. So as you can see here, it will just print out the content of the string, one letter on each line, because that's how print works. Obviously, you can do all kind of other things with it, so not just print out. And one more note that I actually should fix in the slides, that the old is, so when I learned programming, and still I think in many places, they accepted the common thing is to have a single letter variable for these loop things. And I think that's the reason I use the letter C. But recently I reached the conclusion that it's way better to have at least 2 or 3 letters for this variable as well, because then it's going to be easier to search for it. Now, if I look for the word the letter C, it might appear in all kinds of places in the program. If I have if I code it char, or I don't know, whatever name that explains what it is actually, then it's going to be easier to see it and to locate it. Okay, that's just a generic suggestion that I should also fix in the slide. Or maybe I should leave it this way so I can always remember to explain this concept. Exactly the same idea of for loop can also work on lists. And reminder, we haven't really learned lists yet. We'll do that later on. So a list would be just a bunch of values in square bracket and separated with commas. And in this case, these are just a bunch of words or fruits or whatever these are. Okay, and here the construct is exactly the same. So I say for some variable name in, and I don't even have a variable here. I could put it in a variable, but I just have the thing here, the data, the raw data, the literal data. So this goes over the elements of this list, and the elements are apple, banana, peach on their own. So you can see each element on its line, on its own line. Okay, so for loop can go over characters, can go over lists, can cover everything which is a generic term for this is iterable. So you can iterate over them. That's the generic term for all of these objects, that you can iterate over them. There is a function in Python that's called range that also returns this an iterable that you can iterate over. And you will iterate over the numbers, the whole numbers in that range. So this range gets, in this example at least, it gets 2 parameters, 3 and 7. This means that the range provides you this iteration over the numbers, the whole numbers between 3 and 7, where 3 is included and 7 is not. So 3, 4, 5, 6. And here I iterate over and print out the result. Okay.
What sort of parameters can you give this function?
So I think actually it can have it can have 3 parameters, in which case the third is the step, but it defaults to 1. And then if you give 2 parameters, 2 numbers, then it's from till. And if you give it to only 1 variable, then it's 0 till that number.
Right, and you can only give it a number, right? So it's not like you can, I don't know, if you have a list, then work with that and give which range of the list you want to work with.
So because the list has indexes,
right?
Indices or whatever it's in English. So 0, 1, 2, 3, each element has its own location.
Right, so you don't need the function.
No, so you could use the range function.
Oh, okay.
To go over the indexes and then get the right elements.
Right.
That's what you would like. You could also, get a slice of a list in a similar way as we did with the strings. We'll get there when we look at strings, and then you can go over that too, if that's the preferable way. Okay, but the range function can only get numbers and can only iterate over numbers, whole numbers. Okay, so I mentioned that these things are called iterables and or iterators. Slightly the definition of these two things are slightly different. Here there's a link to the explanation of this term. It doesn't matter for now. In the advanced part of this course that we might cover later on, but for now that's not planned. We actually go much deeper into this whole idea of iterables, because you can create you can create yourself really fun iterables. For example, one that goes over a specific type of DNAs. And then you just create this iterable and everyone can use it without knowing how exactly you do that, going over these values. Okay, so you can have a really nice separation between the person who knows how to iterate over something and the person who just doesn't care, just want to go over them and do some other type of research on them. Okay. Okay, so we have this for loop, and which we saw earlier, and it goes over all the elements. But sometimes we encounter something in our iteration that causes us to decide that we don't want to iterate over anymore. Okay, let's say you decided you want to go to have 10 rounds around the building running, and after 3 you got tired, so you want to break out, okay, from this. So this is the same idea here. We have the variable, we go over the string using the iterator, and then, well, usually within a condition, we call break. I mean, if you don't have a condition, then it means that it just goes there and breaks out of the loop. So that's why it's almost always with a condition. And then if this condition is met, then we call the break function, or actually it's a statement. So we encounter the break statement. And this basically breaks out from the loop. And let me just, for break, let me just fix this one. No, what was the name? For break. So this is the code, and I wanted to add something just to say here. Okay, so we can see when we run this that Python for break. So we can see that after that we get to this point. So let me show so when we leave with the break, we leave this loop, we get to the next statement. Okay, and that's it.
Does this essentially do the same thing as a while loop would? Because you give it a condition,
Right.
which is...
Soon I'll show you the while loop and how is it constructed. And in a way, well, there are connection between the two. So there are languages where you don't have both, you have only one of them because you can implement one with the other. So you can have similar behavior, but not exactly, because here you actually have to tell it up front that txt, this is what you are going to go over. So it will stop even if there is no, so in this case we are breaking out if there is a space. But if you get an input that has no space, it will break out and it will stop when you get to the end of it, so it's not exactly like a while loop. Though I could implement the whole thing with a while loop. So with the while I could implement this thing. It's just clearer to implement this way, I think. Right. So there is another tool in loops which is called continue, that says, okay, I'm in the iteration right now, and the iteration, so the iteration has multiple commands right inside, and I don't want you to do the rest of this iteration, go to the next iteration. Okay, so in this case we said, okay, we go over the elements, and eventually we want to print out each element, so each character. But this statement says, if you encounter a space, then continue. So go to the next element. Don't do this. Okay, continue with the loop. That's basically where the word comes from. And when can it be useful? For example, you go over a file line by line, okay, and you're searching for something in each line. But you know that there are some comments in this text, okay, that let's say all start with a hash mark, like in a programming language, just to make it easier. And then you can say that if you encounter a hash mark at the beginning of the line, then don't bother doing all the research on that line. So continue to the next line. That's one of the cases when it can be really useful. Okay. So here in this case, well, it's just a print, but think about it that this has some more complex thing that you don't want it to be done on certain elements. Okay. So that's the other thing that you can do. And also, this is also, I mean, usually, maybe always, is inside some condition. Okay, and now I have a slightly made up exercise example that have both. Okay, so here, I mean, I couldn't really come up with a real world exercise that's simple enough to show here. So here I just have a hello world, just a text, and go over. Now this time I already, you see, this time I already fixed it. So I have 2 letters iterator variable. The first thing that I check whether it's a space or not. And if it's a space, then I continue. So I don't do any of the rest of the checks. So I don't want to handle any of the spaces. And then the next check is I check if it's an R character, and then I break out from the whole loop. So, and then I print out the whole done. So to see that we arrived there. So it will print out hello, then the space it jumps over basically and starts WO, but when it encounters the R, then it leaves the loop. Okay, and then prints the done because that's there anyway. So you will see as you write programs that sometimes you need to, well, either stop the current iteration and continue with the next one, or stop the whole thing and break out from the loop. And there are languages, so let me just another explanation here, both with the for and the while loop. So people many times think about things that, okay, for example, I get some data from the user, and then I check it, and if it's incorrect, then I go back to the first jump back and do it again. And some languages support this kind of programming of saying go to some other location. But more or less, none of the modern programming languages does this. If you need to do this kind of an operation that get some input, then check, and then get the input again until I actually get a correct value, okay, then you need to wrap it in a loop and say, okay, in the loop, ask me. So it's a slightly strange way of thinking it, because normally, and that's how I hear people explaining it, oh, I'm going to ask the user something, and then I check it, and if it's not correct, then I ask the user again. And then it's a little bit get lost, because, okay, I still have to check it again and still ask again, and there is, basically, I have no idea upfront how many times I'm going to ask. I'm going to ask until the user actually types in something correctly, for example. Okay, so this was the for loop. The while loop looks like this. I have while, and then I have a condition, and then inside the condition, inside the colon, and then indented the content of the while loop. So this will, while this is true, do this. That's sort of the English explanation. So here in this case, I have a variable outside, which is called total, that starts with 0. And I say, okay, run this loop as long as the total is less than 100. And then inside the loop, I generate a random number and add it to total just to have it increased. Okay, but this can of course be all kind of other things. So while, as long as you remember the flag that we talked about, that you can have a variable called a Boolean variable. So you can say that found, let's say outside there is a variable called found, which is false, and then say while not found, search for it. And then inside the loop, you do some searching, whatever that happens to be. Okay, so go to some database, or, okay, why haven't received Nobel Prize, do some research. That's the basic, like how to write programs. Okay, so this is a while loop. Okay, so let's change slightly this while loop. Now I have total, and I write while total is greater than 0. Okay, print total, and then increase the total. So sounds good. I mean, same thing. I have a condition and I do something. And if I run this, then you'll really, really quickly see the numbers going up till very high. So let's call it. Let's run this program. It's still in this directory, yes. While, now in the name of the program, I already have the clue. So this is just running. It will never stop. It's an infinite loop. How can I stop this? Okay. So.
I don't know. Maybe you need to press something. Press enter. I don't know.
Standard way to stop these things is pressing Control-C.
Control-C.
Control-C stops usually the programs like this, and then you can see Python even actually in Python it catches it and then gives an exception. So we can actually know that someone pressed on the Control-C. But now we stopped it, and it's not running anymore. So this is called an infinite loop, not something that you probably want to do, but can happen. So this is an infinite loop because my condition will be always true, because it was true at the beginning, and I just add numbers, increase the number. So obviously this is a bug in the code, and not recommended to do infinite loops because they will never end. Okay? But, okay, so let's see something, or it's not but yet, the but will come later, okay, for this. Sometimes you have a loop with a really, really complex condition. So for example, in this one, I don't even remember what I wrote here. So I said, okay, this will this loop will go on this while loop, as long as the total is less than this, I don't know so how many digits are here, million or milliard or whatever number, and as long as the, if we divide by 17, then the remainder is different from 1, and as long as the square divided by 20 of this number divided by, so it's a complex thing. Okay, the whole point is that it's complex. It's hard to read, hard to understand what's going on. Okay, it works, but it's hard. So one of the things that we can do is that we can break up this condition. We can say, let's say, we put here the most important condition, and then inside the loop we have these breaks, because we can use break in the while loop as well, just as we did in the for loop. So both break and continue can be also used in both for loop and while loop. So we have this break now. So now instead of having a huge and mostly unreadable condition here, we have a condition here, and then inside we have these little conditions that say, if this is the case, then break out. So the interesting part is that I had to replace the condition to turn it around, because in the original condition, this was as long as this is true, go on. And now I had to turn it on the contrary and say, once it's true, break out. So now I have to turn it around. So this was when run as long as the total divided by 17 has a remainder different from 1. And now I say, if it's 1, then break out. Okay, so I have to be careful. But this change allowed us to hopefully make the code more readable. Because now I can go and say, okay, I see if I'm going to run till a milliard or whatever, this number, and I do some stuff, and I say, oh, and if this is, if I divide by 17 and remains 1, then I leave the loop. So I can, it's much easier to understand each piece on its own than together.
Right. So in this case, with the previous writing, so all of these conditions have to be met for the loop to continue, right?
Right, because because we are ending together.
Okay, yeah. So if it was an or,
yeah,
then how could you do that with a break?
So if this was an or well, yeah, if this,
you don't really do ors in while loops.
That's an interesting question. If this or this, then the while this or this, then inside probably I'll have to have the so then I'm not sure that you can solve it.
Right.
Yeah, well, you can play around. I mean, there is the De Morgan rule. So if you there is a rule for these conditions. So if you negate, you can negate the whole thing, say not on the whole thing, and then you have to, and then you replace the internal. Well, okay, let's. Law, not rule. Sorry. So this is for sets basically, but for logical operators is the same. So you can say that if this and this. Sorry, this and this, okay, and if you say not, this on the top, this says not. So if I say, and this sign says and basically. So if I say it's both of them. So in this and this, and if I negate this, this is the same as if I turn it around and put an or there. So I can play with this. I guess we have to separate of this. Maybe I show how to use this rule to change a condition. Okay,
right.
You can change an and to an or, and then you can think about that way. Okay, but there is a reason why I used and in the example, because that's the easier way to show it. Okay, so I'll try to create an example with ORs and see how to do that. Okay, so anyway, this is how I broke it to smaller pieces. But you could come and say, okay, but what is special with this and this as opposed to this one? Why this condition was left there and the other two came here? Why not this one remains there? Okay, and maybe in this OR case, it might be obvious or might be understandable because that is sort of what that limit of the number, and then we are going over the number. But in other cases, there is no real point of no special speciality of any of the conditions. So there is another way, and even further, we can go even further and say, bring even that condition inside. And in the while, we just say while true. So basically, oh, bless you. So basically, basically what you need a break? No? Okay. So basically what we are saying, while true says never stop. So if I didn't have these break conditions, these conditions with breaks inside, then this would also become an infinite loop, because it say as long as true is true, run, which is always, okay? So this in itself would be an infinite loop, but because we have these breaks inside, that's why it will eventually, at one point, stop, okay? I mean, worst case, when we reach this condition and then we reach I don't know, this large number. And I guess I don't know. So these numerical conditions are, I've just made them up. So I have something complex that I can't understand when I look at it easily. And I managed to it because I don't understand them. Okay, right. So this is what, and what I mentioned, that you can also use continue. I don't know if I have an example showing when to use continue. Maybe I have in the next one, right? So, but let's have a use case actually. So here is one that I sort of started to mention, but not exactly. So here I asked the user to type in their ID. And normally what usually people who start programming think is that, okay, I ask the person the ID, and then I check if the ID is true, and if not, then I ask it again. And then they implement it this way. So they ask the user an ID, and then they say as long as or while and in this case, the only check that I do on the ID is the length, because I didn't want to have more complex checks. But so I check if the length of the ID is 9 characters. And I say, as long as the ID is not 9 characters, okay, ask me again. And sort of works, right? But there is a bug here. And, or at least that something that bothers me very much. Here, the output is ID colon space. Here, it looks ID. And how could this happen? First of all, it's not a big issue, okay, right, at this case. But how did this happen? Well, I guess originally the person wrote here the same as here. And then someone told, it's told it's much better if there is a colon in the question and the space to write something. So the person checked it and fixed it here, but forgot to fix it here. Because the person who was checking it always typed in the ID on its first try, never got to that one, okay? Good. This is quite a common issue, the repeating or the stuff we do in programming. And programmers like to think about the expression dry, which is do not repeat yourself. So you would like to write a program that's dry, that doesn't have repetitions. So if you would like to do the same thing, then do it in one place and then maybe call it a function. In this case, how could we change this to eliminate these duplications? We can't right? Yeah.
No, I'm not too sure.
No. So if we remove this, okay, the first one, then we have a problem because now we would like to use the ID str before we even ask for it.
Yeah.
Okay, so we need to have the ID str in order to check if it's true. So the way we can solve this is that we have a while loop with a true. And then inside we ask the user, and then we check, and if it's correct, then we break out. And now we have a single place to ask, and then we check inside, and then that's done. Okay, and it's slightly different from how normally people think, because normally you think, okay, I asked once and then I check, but here we have to sort of break this train of thought, or I don't know, this the way we think, and say, okay, we have to wrap the whole thing into a while loop, and then start the question. Okay, and that's one place where it's often used, this while true statement. Okay, there is another thing which is actually quite similar. In some languages, there is a construct called do while, which actually changes the order of things. So you have the internal part of the while first. That's so it says do whatever you need to do, and while then there is the condition. And that's exactly solving this kind of problem, because it says you first do whatever you wanted to do, and then then is the first time you check the condition, which is sort of what we wanted earlier. But Python doesn't have this condition, this do while loop. And why doesn't have? Because it's simpler not to have. So it's a question of how complex or simple the language is. And because you can easily solve whatever you want it to have is a do while, you can solve it this way. So you have the whatever you would like to do, and then you have the condition and break. So it's exactly the same. So again, if people who come from languages that have do while loop, well, I'm sorry to say, but Python doesn't have. But it's easy to solve the problem that you encounter, that you would use a do while loop with this construct. Okay. And here we also have the same idea. So an example with a while with many continue calls. So I mentioned that you can use the continue with while. Here, that's a sort of a pseudocode, not exactly working. So here I get some line. So I have a loop. I get the next line, for example, from a file in some way, or from a database, or next something. And then if it's the last one in some way, if we recognize this is the last one, then we break out. So this is not a real code because we don't have the variables. I'm just trying to create something. And then we can have all kind of these things that, for example, what I mentioned, that, for example, if the line is empty, then don't bother the rest of the research, just continue to the next one. If the line has a hash at the beginning, right? So it's a comment, then don't bother, continue to the next one. If the line starts with 2 slashes, then that's a different type of comment, let's say. Don't worry, continue. And then here is the stuff that you do really. And this is a quite common code when you're going over some data, a file or something, and you know that there are certain items that you don't want to bother looking at. You might, I mean, I didn't show that, but you can have a loop, and inside another loop, and inside another loop. Theoretically or technically, you can have them. And Python allows it. And then people ask the question, okay, so now if I have a loop inside a loop, and I'm using the word loop because it's either for or while, doesn't matter. Okay, so, and then people say, okay, so now I know how to break out from the loop. How can I, if I have a loop inside a loop, how can I break out from when I'm inside, but I would like to break out from the external loop as well? So not just from the internal. From the internal, it's easy, you just code break. And some languages support the idea of breaking out from the external loop as well. Python doesn't. Some languages support it with something called a label. Python doesn't support. So the sort of the explanation is that if you really need you feel the need to exit or break out from an internal loop, then it probably means that your code is too complex. Convert one of them to a function, and then suddenly you don't have that problem. Okay, so that's sort of the message there. We talked a little bit about exit versus return. So now I even have a slide about it, just because at this point already, almost all of my students get confused. Okay, maybe because I'm not teaching well, but it's also slightly confusing. So exit, no matter where do you put it, will leave the program. Okay, nowhere you at. Return, you can only use return inside functions. You can't use it anywhere else, and then they will stop that function from running and will go to the next statement after you code the function. Break break can be only in loops, for or while loops, okay? And then they will stop the execution of that loop and go through the next statement. And obviously you can have a loop inside a function, but the break will only work on the loop. But you can have the return statement in the loop if the loop is in the function. Okay, so the whole idea is that the function can wrap any code basically, and then in the function you can have an exit and just leaves the whole program. You can have return, it will leave. And if you have a loop in the function, then you can have a break in the loop, but it will only break out from the loop. So, and continue, it has nothing to do with all these things. It's one of the these magic keywords that will just continue the loop. So it will not break out, not stop anything. Okay, I hope that I haven't made it even more confusing. Maybe I should have like a lot bigger example of all of these. Anyway, we got to the exercises of this chapter, and let's go over them quickly. So now we get to the point where we asked a couple of chapters ago that if you have a string and you use index to find the location of some other string, but you wanted to know how could I get all the locations if it's repeatedly there. So now you have the loops, so now you can figure it already out how to find all the occurrences of the same substring, the locations. And now we can also continue with the number guessing game or the one-dimensional space fight, because now we can already continue. So this was I think I just copied it. This was level 0 that we already saw, to just think about the computer thinks about the number and this guess. And then you can step by step or level by level, you can improve your code, make it more complex, add more features. So don't do the whole thing at once. I recommend you the first level and the second and so on. The first level that the user can guess several times. Okay, and then the next level, that besides just guessing, the user can also press X, enter, and then it will leave the whole game. So exit the game, and oh, I can't solve this, I just want to leave it, okay? S, if I press S, it would be show me the actual value that's hidden, okay? So it's like cheating, but it's a useful thing. But it shows me once, and then it lets me keep guessing. Okay, so it can be, but whatever. I just wanted to have some feature like this. And then we have a slightly more complex one. So the next feature we are actually going to really read because of the one in the level 5. So at level 4, it's a little unclear why do we need this feature. But we would like to have a debug mode. So if we are in debug mode, then every time the user is about to guess, or before the user guesses, the computer, no, after the user guesses, okay? So once you guessed, the computer will show you whether it was small, less than or greater, but it will also show the hidden number. As it's different from the S, because the S shows only once. D, when you are in debug mode, then every time you guess, it will show you the number. Now you would ask, why would you need this? And you need this because there is the next version, the next level, you will have a moving mode because it's a space thingy, so it also moves. So basically you get it, there's a hidden number, you guess, if you didn't hit it, then it moves a little bit. So the number changes a little bit. It can grow by 1 or 2 or shrink by, become smaller by 1 or 2, okay? So basically it can move a little bit. Think about a spaceship that can a little bit move, and then you guess again. So just to make the game harder or impossible, depending on whatever, okay? But so this is the move mode. And when you are trying to debug the move mode, then it's good to have to be able to be in the debug mode. So how does the debug mode work? When you play the game, if you press enter, if you press D, enter, then you enter the debug mode. And you are in debug mode until you press D again and enter, and then you leave the debug mode, okay? And then the same is the M. So you start the game with normal mode, and then press M, enter, you switch to move mode. In move mode, every time after you guessed, the computer randomly will change the number a little bit. Okay, and right, and then level 6 is that you allow the user to play several games. So when the game is done, then you offer the user to play another game. Okay, and then you might also want to have a key N that will skip the current game. So X would leave the whole game, but N will only just go to the next game. So, okay, I can't find this space thingy, so let's try another one. That's sort of the idea. And so this is the game, lots of levels. And I think I haven't written it up, but I should, that later on we can have more levels when you actually save in a file the, what was the how fast you, the top scores. So how fast you manage to find the number, okay? And then you would type in your name and so on. That I should add this exercise because that's a good extension to this game when you already know how to deal with files. Okay, and so that's this exercise, and we have more. Okay, we have a lot more exercises here. So this is now way up. Do you know the game Mastermind? Surely you know. Mastermind is when you have a board and you hide 4. You have 6 colors. You hide 4. One player hides 4.
Oh, right. Yes, I do.
You know.
Didn't know it was called like that.
Right. Okay. So you hide 4 colors, and the other player who didn't see it puts in 4 colors from the 6, and then you put in white and black sticks. Accordingly, I think if you put in a black stick, if there is a color that matches the same location, so there was the red in the same location as your red, and a white stick if only the color match. So there was a red and you have a red, but it's not in the same location. And the simplest way to play is that each color must be different. Okay, but you can have more complex when you can have more colors. Now we don't have colors here, so we can use digits, and then you can limit it to 6 digits. You can play, I mean, this is a whole set of games you can see, you can create. So the computer thinks about 4 digits instead of the colors, and you guess, and then the computer tells you, I think the star comes before instead of the black stick, so saying that it's in the location. So 2 was in the same location here, and star plus plus because 2 was in the same location, and there was a 1 and there was a 5. Okay, and but not in the right location. And then so you can play it. Okay, so that's the first part of this exercise. And then just blame on some of the previous of my students. The next part of this exercise is do the part of the user. So you are the person who think about a set of numbers, and now the computer has to guess. Now this is going to be a very interesting algorithm. You can actually look up the algorithms how to do this, but it's not easy. Okay, the second part, but it's a very interesting exercise. You don't. Almost obviously, you won't find the optimal solution, because the optimal solution is very, very not logical.
Right.
It's some really, really strange way of solving it. I mean, I definitely don't know it, so I never tried it. But you can read it in the Wikipedia, because this then created, I don't know, research later on. So it's interesting thing. So this is another apply. And actually, if you create both sides, then you can think, how could you actually make the computer play against itself? Okay, so just how to, I mean, you can run the programs in 2 windows, and then you yourself move around the results, but you can also think about, okay, how can I connect the 2? And actually that could be a really interesting extension of these exercises, and showing them how to do that. Okay, another one. I don't even remember how good is this. I think, but let's just go over it and maybe try to do this. So you want to have a program that gets a string on the command line and tells us the number of different characters, so unique characters. So because A appears multiple times, I don't care. I only care about the fact that A appeared once. So A, B, C, D, in this case 4. Okay, so try to do this one. And so you have plenty of exercises now. Enjoy. Any questions with the exercises, with the content so far?
No, I think it's all good now. Okay. I'm sure I'm gonna have some questions after doing the exercises, but okay, let's get to that later.
Good. Yeah, and then if during the exercises you have questions, then we can see how can we make it also recorded, so other people will also see what kind of questions came up, and then see the answers as well. Okay, so thank you very much everyone for listening, and see you in the next video, and really enjoy the exercises. It's gonna take time. Okay, so this time it's gonna take time. Right. Okay, so goodbye.
See you.